Can I turn the lights out so this shows up better on video? All right. No falling asleep. Okay. We're going to start something called piecewise functions. And in my opinion, piecewise functions are really easy. And piecewise functions are used by like shipping companies like UPS or FedEx or even the U.S. Postal Service, because what they do is up to a certain amount of weight is this rate that they charge you to ship something. Up to another certain weight is another rate that they charge you to ship something. Added up to another rate, so on and so forth. This is how all of these companies operate. Obviously, a small little envelope is going to cost you a heck of a lot less than a box that's 4 feet by 2 feet by 3 feet. Okay, and obviously the weight also has something to do with it as well. Okay, so a piecewise function, first thing they do is they make it look fancy by putting some of these brackets. They have something like this, and then they have this. They'll do 3x minus 2, and then you have 5 here, and then maybe you have negative 2x plus 1. Seem okay so far? And now they're going to restrict you, so you're going to create some sort of domain. So this might have a domain here of negative infinity to 3. This might have a domain from 3 to 5, and it might have a square bracket here, which means it would end there. And this might have an open bracket from 5 to infinity. Okay? So this just means that I have 3 straight line linear equations. And this kind of goes along with what's in the blue notebook, but I'm kind of going off the cuff a little bit. So we have 3 straight lines that we want to draw. But the straight lines could start and end in different places. Okay? Let's go to our fancier screen. Okay, split it. There. All right. XY axis still with me? Okay. So I'm going to do this. I know 3 is right here, and something's going to take place at 3. I know 5 is right here, so something's going to take place at 5. Okay? That's basically where your graph could turn a certain direction. So I'm going to graph 3x minus 2 as a normal line, and then I'm going to erase a portion of it. So don't draw the line yet. Watch when I draw. But let's draw this portion of the line green. So it has a y-intercept of negative 2. Put a dot. I'm going to go up 3 over 2. Or just 3 over 1, excuse me. There's my second dot. And then from there I could go up 3 again. Over 1. I go up 3 again. Over 1. Okay? So if I connected these dots to each other, this is basically that line. Does that make sense so far? So let's just leave that for right now. And let's draw another line. We'll do this purplish. What does the line y equals 5 look like? I know it's straight, but what kind of straight line? Is it vertical or horizontal? Y equals 5. Y equals. So function at x is the same thing as y. F at x is the same thing as y. So y equals 5. So that's a horizontal line at 5. So 1, 2, 3, 4, and 5. Is that okay? And then I have another line, which is negative 2x plus 1. So maybe I can do this one in blue. That'll work out. So I have a y-intercept at 1. I'm going to go down 2, right 1. I guess I could keep going down 2 and right 1 and just continue this. Is that okay? Now, I did it all as lines for a reason, but now I want to go ahead and start restricting those lines a little bit. Okay, so the green line is going to go from negative infinity, so way this way, way to the left this way, up to 3 in the x direction. Okay, so let's use a crayon. Which one do I want to use? Can't use I guess the highlighter is going to make it always straight line, which just drives me nuts. All right, so the green line, let's do that. So the green line, we're going to go from negative infinity up to our 3. So going all the way up to there. So now I'll go boom. I'm going up to 3. Is it an open circle or a closed circle at 3? Open is parenthesis. Okay? The rest of this portion of the line I'm going to erase. The rest of the green line I'm going to erase. I don't need this. Oops. Aren't you working on me? Okay? So that's all of that green line that I need. Go back to the crayon. We'll go with the purple. The purple of 5. I'm going to go between 3 and 5. 3 and 5 with a purple. God bless you. Okay? So at 3, it's an open dot. 3 is an open dot. 5, we have a closed dot. The rest of the purple line I'm not worried about, so I'm going to go ahead and erase it. Is that okay so far? And then the blue line, we'll do a blue crayon. Blue line from 5 down and we need to go with it is a open dot at 5. Oops. And the rest of the line I'm not worried about. That is my piecewise function. Okay? So I drew the entire linear equation like it would be there, and then I put the restrictions in place. Shall we do another? Now's about the time that you get the shout out of whenever you have business in life. When you go to the post office, I got email. You're right. Dear. Just take a look at how these sound. Okay. One last thing I want to show you that doesn't include piecewise. It is a piecewise, but what it's going to do is, let's say we had this. Okay, so they might give you a problem that looks like this, where you have one line that's 3x minus 7, which is restricted. You have one line that is negative 5x plus 6, which is also restricted. And I might give you this. I want to know what the function at 4 is equal to. So which of those equations do you think I would use in y? Y at the top. So 4 falls in the bracket of negative infinity to 7. So if I want to know what the function at 4 is equal to, I'm going to take the top equation, do the little bit of math. So 3 times 4, that's 12 minus 7, which is 5. Okay? What if I had function at 10? Top or bottom? Bottom. Why is that? Because 10 falls in the region between 7 to infinity. So I get negative 50 plus 6. It's a little blurry. We get negative 44 there. Okay? Trick question. Function at 7. Good. Some of you are saying both, which is a good choice, but it's actually, it doesn't exist because 7 doesn't fall within our boundaries. Because we go from negative infinity to 7, we don't get to 7, and then we go from 7, just above 7, to infinity. So this doesn't have a solution as far as this question goes. Now, if I had a problem where this was a square bracket, that means we include 7, which means you would plug that into the other one. But as we had it originally written, there's not going to be a solution to the problem. Seem okay? Any questions? All right, here is your assignment for next time. Let's see, page 130. Page 130, 13 through 45 odd. Whoa, wait. Nope, take that back. 35 through 45 odd.
35 to 45 odd.
35 to 45 odd. 61 and 64. So that's your assignment. Things that I will tell you that on next week, Wednesday and Thursday, we have the 2-part test. Okay? Now, the first part of the test, well, one of the parts of the test, you're not to use a graphing calculator on, which I'm okay if you use a 4-function calculator on it, meaning add, subtract, multiply, and divide. If you don't have one, don't panic. You can be able to do without it. The other part, you can use the graphing calculator on. But that's what I have for you guys between now and next Wednesday and Thursday. Sound good?